Good afternoon, sir.
Good afternoon, sir.
Good afternoon, everyone. Okay, now today we discuss on about alternating series. So, what is alternating series? Alter. Mute, mute. Anmol, Anmol.
से रिमूव कीजिए।
Okay. Okay, alternating series. Uh, it is a series in which the terms are alternatively negative. That means first term is positive, then second term is negative. So definition is a series in which the terms comes alternatively. That means the terms are alternatively negative. Negative is called a alternating series. Now, to test the convergence of alternating series, there is a rule. That rules is called Leibniz rules. Leibniz. Leibniz rule for convergence. For convergence of alternating series. Now, it's statement of Leibniz rule. First is in the series of alternate or in alternating series, each term is numerically less than its preceding term. Each term is numerically less than its preceding term. That means the sequence of term is a decreasing sequence. So actually alternating series is like what? U1 minus, second term is negative U2, third term plus, like that. So first condition is each term is numerically less than its preceding term. That means U1, that is value of U1, numerical value of U1, U2. So UT is less than its preceding term. Okay, that means U1, U2 and U3, this sequence is actually decreasing sequence. And second condition is limit n tending to infinity un is equal to 0. If these two conditions satisfies, then we can say that the series is un, and un is an alternating series. It must converge. Example. Discuss the convergence of the series. Series is -1 to the power n by n square plus 1, where n is equal to 1 to infinity. Since there is a -1 to the power n, so this is an alternating series. So for alternating series, we test by Leibniz rule. So first we find un and un plus 1. So un is mod of un is equal to n by n square plus 1, and un plus 1 is equal to n plus 1. This find the difference. Un minus un plus 1. This n by n square plus 1 minus n plus 1 squared plus 1. So LCM n square plus 1, n plus 1 squared plus 1. So n into n plus 1 squared plus 1 minus n plus 1. Now n square plus 1, n plus 1 squared plus 1, and ऊपर में होगा n into n plus 1 square. So finally we get actually this difference is n square plus n minus 1. Now this is actually will be greater than 0 because n is a positive term greater than 1. So n square plus n will be always n square plus n will be always greater than 1. So n square plus n minus 1 is greater than 0. Greater than 0. That means नीचे जो है ये सब greater than 0. That means this term will be greater than 0. That is positive. So that means mod of un is greater than un plus 1. So first rule, first assumption holds. First condition of Leibniz rules hold, and second condition is limit n tending to infinity un must be is equal to 0. So limit n tending to infinity mod of un is equal to n by n square plus 1. So this will be 1 by n plus 1 by n, that is 1 by infinity plus 0, that is 0. So second condition also holds. So this means second condition holds. So by Leibniz rule, so by Leibniz rule, the given series, the given alternating series is convergent. Okay. Now example 2. Test the convergence of the series. Which series? Series is 1 by 6 minus 2 by 11 plus 3 by 16 minus 4 by 21 plus 5 by 26 up to infinity. Now we have to find the nth term. Un is equal to minus 1 to the power minus 1 to the power n plus 1 or n minus 1, because first term is positive. So minus 1 to the power n plus 1 n by 6 11, so n by it will be 5n plus 1. So un is like that. So mod of un is equal to n by 5n plus 1. Mod of un plus 1 is equal to n plus 1 by 5n plus 1 plus 1. Now we have to find the difference un minus un plus 1 is equal to n 5n plus 1 minus n plus 1 5n plus 1 plus 1 and this is 5n plus 6, n into 5n plus 6 minus n plus 1 into 5n plus 1. So 5n square plus 6n minus 5n square plus 6n plus 1 and नीचे 5n plus 1 5n plus 6. Now 5n square 5 is 6n cancel, so minus 1 by 5n plus 1 and 5n plus 6. Now 5n plus 1 greater than 0, 5n plus 6 greater than 0. So actually total term is less than 0 because there is a minus 1. That means un un minus un plus 1 is what, less than 0. So this, that means mod, there is mod. So the sequence is not an decreasing sequence. That means each term is not numerically less than the preceding term. Each term is not less than its preceding term. So the first condition does not holds. Also second condition does not holds. Second condition what? Limit n tending to infinity un. So limit n tending to infinity un is equal to mod of un n by 5n plus 1 to infinity 1 by this. So limit is 1 by 5 not equal to 0. So both the conditions are not satisfied. So by Leibniz test, hence by Leibniz test, we can say that the series is not convergent. Okay, that means it is an alternating series. So this is an actually it is oscillatory series. This is oscillatory series. Now, another example. Example 3.
Sir, it may be divergent too.
Divergent, no, this is oscillatory series. Divergent, no, oscillatory series. Plus minus, plus, because the 1 minus 1 plus 1 minus 1, this series. This is an oscillatory series. Okay.
Okay,
Yeah,
sir.
you may say that it is divergent, because for convergent of a series there may be only one limit, right? Only one limit. But for this series, this is an oscillatory series, oscillatory and series, and there is two limit, that is 1 plus 1 and minus 1. So this is divergent. You may say that this is divergent. Now, example 3, it is 1 minus 2 root 2 plus 3 root 3 4 root 4 and so on. So test the convergence of this series. So this is an alternating series, and un will be minus 1 to the power n plus 1 1 by n root n. So mod of un is equal to n root n, that means n plus 1 to the n to the power 3 by 2. Mod of un plus 1 is equal to 1 by n to the power n plus 1 to the power 3 by 2. Now n plus 1 is greater than n. That means n plus 1 to the power 3 by 2 is greater than n to the power 3 by 2. That means 1 by n to the power 3 by 2 will be equal to this. So that is un is greater than un plus 1. Okay, that means the first condition holds. First condition of the Leibniz series holds. Now second condition. For second condition, limit n tending to infinity un 1 by n to the power 3 by 2. So as n tends to infinity, it will be equal to 0. So second condition also holds. So by Leibniz test, the series un is convergent. Now, alternating convergence series, alternating convergence series are of two types. Alternating convergence series are of two types. One is absolutely convergent series, convergent series, and another one is conditionally convergent series. Conditionally convergent series. Now, when it is called absolutely convergent series. Absolutely convergent series when if the series u1 plus u2 plus u3 b such that mm, uh, u1 plus u2, no, it may write uh, this is alternating series, so u1 minus u2 plus u3 minus u4 plus, like, now this is alternating series. This will be called an absolutely convergent series when u1 plus u2 mod of u1 plus mod of u2 mod of u3, this is the a convergent series. Then if this is a convergent series, then we say that u1 minus u2 plus u3 minus u4, this series an absolutely convergent series. Okay, example. Example, take example 1 minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square, this. So here un is equal to mod of un is equal to nth term is 1 by n square, and un plus 1 is equal to 1 by mod of un plus 1 is equal to this. Now here which term is greater, n plus 1 greater than n, so this square is greater than this, so 1 by n square is greater than 1 plus n square. That means mod of un is greater than, so this is a decreasing sequence, so first condition holds. First condition is un greater than un plus 1. First condition for Leibniz test. And second is n tending to infinity, un equal to 1 by n square, that is 0. So second test also holds. That means this series, this alternating series is convergent. Convergent by what? By Leibniz test. Now we have to check it is a absolutely convergent series or not. So for absolutely convergent series, we take the series 1 plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square, this series, to check convergence of the series. Check convergence. Now this is a what series? This is a
Power.
P series, na? This is a P series
And convergent series.
huh?
P series convergent series greater than 2.
This is convergent series. So for P series, or P equal to what? P equal to 2, and 2 is greater than 1. So since it is P greater than 1, this is an convergent series. So this is an convergent series. So that means the series is convergent and the series is absolutely convergent. The given series is absolutely convergent. Okay. Now check this series. Example 2. Check 1 minus this. So is this a absolutely convergent series? What do you think?
No, sir.
No, sir.
So first Leibniz test. By Leibniz test, this is a convergent or divergent?
Convergent.
Convergent.
Okay. So by Leibniz test, this is convergent series. Because 1 by 2, 1 by 3 is a decreasing sequence, and as n tends to infinity, the nth term tends to 0. So by Leibniz test, this is a convergent series. And now 1 plus half plus 1 3 1 by 4, this series is convergent or divergent?
Divergent.
Divergent.
Equal to 1.
Yes, this is an P series. Why? And P equal to 1. P equal to 1 means this is an divergent series. So this given series is not absolutely convergent series. That means the given series is conditionally convergent. That means the given series is conditionally convergent. Okay. Now, discuss the convergence of the series. Series is 1 minus 1 by 3 plus half plus 1 by 3 cube plus 1 by 2 square plus minus 3 to the power 5 plus 2 cube. This. Now first we have to write, and we have to rewrite this series. First rewrite this series like 1 half square 1 by 2 cube, this 1 half 1 by 2 square 1 by 2 cube, this series, and this is minus comma, then 1 3 3 by cube, like 1 by 3 plus 3 by 3 cube, 3 to the power 5, 3 to the power 7, this. Now limit, first I have to Sn, and limit n tending to infinity, Sn will be the sum of this series minus sum of this series. So this is a series of GP, right? Geometric series. So sum will be, formula is 1 by 1 minus r, that is 1 by half. First term is 1. Actually first term is a, then the sum is a by 1 minus r. So 1 by 1 minus r plus, for this series 1 by 3 by 1 minus 3 square. No? What is r? 1 by 3 square. This is r. So sum will be this is 2 minus 1 by 3, and this is 8 by 9, 2 minus 9 by 8, 2 minus 3 by 8, that is this will be 16 minus 3 by 8, this. So this is a finite term. This is a finite term. So finite term, since Sn limit of Sn is finite, that means the series is convergent. The series is convergent. Which series? The above alternating series is convergent. Okay, now check is it absolutely convergent or not. Okay, so for absolutely convergent, the series will be, we have to check the convergence of the series, this plus, because all minus are changed to plus, we have to check this series. Now Sn will be, as n tending to infinity, Sn, this will be same 1 by 3 plus square. So this will be 2 plus 3 by 8. This is also a finite term. That means this series also is convergent. So for absolutely convergent series, the both conditions are satisfied. So the given series is absolutely convergent. Okay. चलो ठीक है, नेक्स्ट क्लास में ये होगा रेडियस ऑफ कन्वर्जेंट एंड पावर सीरीज.
ओके सर.
ओके, नेक्स्ट क्लास में यूनिट 4 फिनिश होगा. यूनिट 4. अच्छा, ये बोलो कि जो तुम्हारा MCQ 2 है, उसमें यूनिट 2 एंड यूनिट 4 कर पाओगे?
So unit 2 and unit 4 or unit 2 to unit 4?
Unit 2 and unit 4.
No sir, only unit 2 दीजिए.
ओके सर.
Only unit 2 sir.
No sir,
Only unit 2.
Yes sir, only unit 2.
Yes sir, only unit 2.
The vote is for only unit 2.
सर कुछ यूनिट 4 भी इंक्लूड कर सकते हैं.
Not only unit 4, not only some part.
यूनिट 4 के कुछ होना चाहिए, ठीक है?
हाँ, कुछ पार्ट रखिए, कंपैरिजन पार्ट वगैरह या रेशियो टेस्ट.
ठीक है. हाँ, मैं कुछ
इंटीग्रल कैलकुलस वाला पार्ट इसके बाद होगा.
कैलकुलस तो नहीं है इसमें
सर. यूनिट थर्ड में कुछ नहीं होगा.
यूनिट थर्ड शुरू होगा, और जो MCQ 2 है उसमें यूनिट 2 पूरा रहेगा. दैट मींस राइट. तो MCQ जो 2 है उसमें सिलेबस क्या होगा? यूनिट 2 का पूरा प्लस यूनिट 4 पार्टली.
सर यूनिट 4 पार्ट में सर उसमें स्टार्टिंग के क्या कहाँ तक रहेगा? रेशियो टेस्ट या कंपैरिजन टेस्ट?
वो होगा बताता हूँ. जो गॉस रेशियो टेस्ट है ना, अप टू हो पाएगा?
यस सर।
So it would be better if it will be up to comparison test only.
कंपैरिजन टेस्ट आगे क्या है? पी सीरीज है, कोची फंडामेंटल। ओके ठीक है, तो अप टू कंपैरिजन टेस्ट।
Thank you, sir.
ओके
यस सर,
चलो
थैंक यू सर।
चलो थैंक यू। और अटेंडेंस डाल दो लिंक में, सेम लिंक।
ओके ओके सर,
Thank you, sir.
थैंक यू सर वंस अगेन।
Thank you, sir.
Thank you, sir.